Hi guys, my name is Manas Adhikari. I am 9 years old. So today we're going to find the derivative of fx equals to radical x minus 1 over radical x plus 1. So first of all, to find the derivative, we had to use the quotient rule. So then, the quotient rule is d dx u over v is closed equals to, you have v times du dx minus u times dv dx, and then whole over v squared. So first of all, that would be equal to v is gonna be it's gonna first of all be dx, and then parenthesis, u is radical x minus 1 over radical x plus 1. So now that means v is equal to radical x plus 1 parenthesis, and then times we have is d, and then parenthesis u is radical x minus 1, parenthesis closed, dx. And that would be minus u is parenthesis radical x minus 1. We have times d, parenthesis a radical x plus 1, parenthesis closed, and then dx. And then this whole over v squared. V is radical x plus 1, and that to the power 2. So now, first of all, we have to find the derivative of radical x minus 1. So then we'll have dx, we have parenthesis radical x minus 1 there, and then so this would be equal to, we have dx, we have parenthesis radical x, and then minus we have dx of parenthesis 1. So now dx of radical x, or the derivative of radical x, is equal to half of x to the power negative 1 over 2. And then minus, the derivative of a constant term is always 0. So we're just going to leave that. So now we're going to find the derivative of radical x plus 1. So then that would be dx of radical x plus 1. So then that will be equal to, we have dx, we have parenthesis radical x, parenthesis closed, and then that would be plus dx of 1. So again, we know this is equal to dx of radical x, so the derivative of radical x would be half x to the power negative half. And then again, plus the derivative of a constant term is always 0. So now we're going to leave that there. So then this would be equal to, we have radical x plus 1. Then we have parentheses, we have again half x to the power negative 1 over 2, parenthesis closed. And then minus, we have parenthesis radical x minus 1, and then parenthesis closed, times half, then x to the power negative half. So now let me erase this. And this, and this. So now we have this, and then we have parenthesis closed, and this would be whole over. We have a v, which is radical x plus 1, parenthesis closed, to the power 2. So now this would be equal to, so now actually we can factor out half and the x to the power negative half. So this would be equal to, we have half x to the power negative half. And then we have parenthesis. And then this would be parenthesis times. And then we have radical x plus 1. And now we can distribute the negative 1 in the radical x minus 1. So this would be minus radical x. And this would be a plus 1. And then parenthesis closed. And then whole over, we have parenthesis radical x plus 1 to the power 2. So now we can cross this radical x and this negative radical x. So then that means we will have half x to the power negative half. Then we have parenthesis closed. This is parenthesis times 2. And then whole over, we have parenthesis radical x plus 1 to the power 2. So now this would be equal to, we have 2 times half is 1. So then we have x to the power negative half over parenthesis radical x plus 1 to the power 2. So now this would be equal to, we have 1 over, we have x to the power half, and then parenthesis, then this new parenthesis radical x, and then plus 1 to the power 2. So now this will be equal to, we have 1 over x to the power half would be radical x. So we have radical x, parenthesis, then we have parenthesis radical x, then plus 1 to the power 2. So this will be the final answer to the derivative of fx equals to radical x minus 1 over radical x plus 1. Have a happy Memorial Day.